yesterday, we started talking about these rational functions. And the things we did, just to review really quick, we talked about vertical asymptotes. How do you find the vertical asymptotes? What do you do?
The opposite of that.
You set the bottoms equal to 0 and you get x equals
-2 and positive
-2 and x equals 1. Now, the vertical asymptote also helps you determine the domain. The domain is all real numbers except
except -2 and negative.
x can't be -2 or 1. Now, what is a whole?
When you have the x value or the equation thing that sounds the same on top and the bottom.
That cancels, right?
Yeah.
So this one doesn't have a whole, right? But look at number 2. Number 2, you had x equals -4 and x equals -3, right? But, in your domain, you would say all real numbers except x can't be -4 or -3. But this has a whole. Where's your whole? At -3 what? You're going to plug -3 into what's left, y equals 2 over x plus 4. If you were to put -3 in here, you get 2 over 1, which is 2. Okay? Now, what we did not do is the horizontal asymptotes. And I told you it's going to take me a while to talk about that, and it is. Let's do it now. I want you to flip over to the other side. Because these are actually easier to do. Horizontal asymptotes are easier to do when they're unfactored. What is a vertical asymptote? A vertical asymptote are the lines that the graph gets closer and closer to vertically but doesn't cross. What a horizontal asymptote is, it's a horizontal line that the graph gets closer and closer to. This is a little tricky because horizontal asymptotes are more for end behavior. Horizontal asymptotes are tricky because a graph can, if you, let's say you have a horizontal asymptote like that, and let's say you have these vertical asymptotes, sometimes a graph can cross a horizontal asymptote. Sometimes, not all the time. But it's more, horizontal asymptotes are more for the end behavior. It's going to get closer and closer to the ends of that horizontal line. But sometimes you will see a graph cross a horizontal asymptote. Sometimes you'll see something like that. But it's rare. But I just want to let you know, you might see something like that. That's what your graphs are going to look like. So, how do you find a horizontal asymptote? Well, 2 things are going to happen here. Actually, 3 things are going to happen. If it's bottom heavy, what do I mean by bottom heavy? If the degree of the denominator is larger than the degree of the top, for example, I'm going to give you an example like 2x cubed minus 6x plus 4 and 3x squared. I'm just making this up. The degree of the bottom here is a 3. The degree of the top is a 2. If it's bottom heavy, like this one, your horizontal asymptote is going to be y equals 0. So all bottom heavy rational functions have a y equals 0 horizontal asymptote. Where is y equals 0? It's this right here. So bottom heavy, y equals 0. Bottom heavy, y equals 0. So let's look at these and tell me which ones are bottom heavy.
2.
Number 2 is bottom heavy. See how that's a 2? And that's a 1. Any other one bottom heavy?
No.
No. If it's top heavy, what does top heavy mean?
Degree of the top
The
is
degree of the top,
higher.
so 3x squared over, I'll just make this up, that's top heavy. If it's top heavy, there is no horizontal asymptote, you say none. Now, if you were sitting in my second or third hour class and it was pre-calc, there are two other asymptotes. If it's top heavy, we have a slant asymptote and a parabolic asymptote. We are not going to learn this in this class. But if you were in pre-calc, a slant asymptote is an asymptote, it's a line, and a parabolic one is a parabola. And how you find them is that if it's top heavy by 1, there's a slant asymptote. If it were top heavy by 2, if I made this a 3, if it's top heavy by 2, there's a parabolic asymptote. You will explore these two asymptotes in pre-calc. We're not gonna do it. It goes deeper, pre-calc goes deeper into these asymptotes, yeah.
What if it's more than 2?
Then don't worry about it. There is none.
Uh,
So in this class,
Okay.
we're gonna do, if it's bottom heavy, y equals 0 is your asymptote. If it's top heavy, there's no horizontal asymptote. And we didn't talk about one more. What if they're equal? Very good. What if they're equal? So this is what you're gonna have. If it's top heavy, what's your asymptote? None. There is none. If it's bottom heavy, okay. What's your horizontal asymptote?
0.
Take that back, please. If it's bottom heavy, what is it? Y equals 0. And what if they are the same degree? What you do is you take the leading coefficient of the numerator over the leading coefficient of the denominator. So it looks like this. For example, if I give you y equals 2x minus 7 over 3x plus 4, see how these degrees are the same? Your horizontal asymptote will be 2/3. If I give you y equals x squared minus 4 over 3x squared plus 1, what would this be? Y equals 1/3. You take the leading coefficient of the numerator over the leading coefficient of the denominator. So let's do these horizontal asymptotes. Start with number 1.
1.
Good job, 1 over 1. So it's y equals 1 over 1. Y equals 1. We said number 2 is bottom heavy, so it's y equals 0. What's number 3? Y equals 1. Number 4,
2.
y equals 2 over 1. Good. And this one, top heavy, none. And number 6, y equals 1. Now flip it over to the back side. What do you think you're gonna have to do on these ones? Yes. Now, do you have to FOIL the whole thing? No.
No, don't you really just have to do the x?
You just have to look at the leading coefficient. So this would be x squared, and so would this. So what would be the horizontal asymptote? Y equals 1. Good. How about this one? This is bottom heavy, right?
Yes.
What's this one gonna be? Y equals, number 3,
1.
x squared, y equals 1. Number 4, same thing, Number 5, same thing. And number 6, same thing. Okay? Now we're gonna start graphing these. So take out that second sheet I gave you. We're gonna put it all together. This is a continuation of yesterday. I am going to show you, there's only 8 actually there's only 7. One of them is, we're gonna throw out. There's a typo. Number 1. What things did we do yesterday out of these? What are the things you recognize in this chart?
VAH or
VA. How do you do VA? What does VA stand for?
vertical asymptote.
What is your vertical asymptote? Good job. X equals -1. How are you going to draw x equals -1 on your graph? How are you going to draw it? You're going to draw a broken line, and I'm going to use my orange highlighter because it doesn't stand out very well.
It's a 13.
Okay, everyone see the vertical asymptote. Now, you could also do for me what we just did today. What's the horizontal asymptote?
1.
We just did it. These degrees are the same, so it's y equals 1. So how do you graph y equals 1? Like that. You could tell me if there's a hole or not. Is there a hole?
No.
Right, none. Because nothing crossed out. Do you think without me telling you, you know how to figure out the y-intercept of this? What is the y-intercept in your own words? Describe the y-intercept. It's exactly where the graph hits the y-axis. And everywhere where a graph hits the y-axis, tell me what you said equal to 0. X. So that's how you find the y-intercept. You will set x equal to 0. If you put a 0 here and a 0
Y equals
here,
2.
you get 2. So this graph, wherever it is going to hit the y-axis at 0, 2. All you do is plug in 0 for x and find out what that is. Now your roots. Your roots, another name for roots are your x-intercepts. That's another name for it. What you do is look at your numerator and you set this equal to 0. So -2, 0 is it's going to hit the x-axis at -2, 0. So your roots and your y-intercept are where you hit the x and the y-axis. So to find the root, what you do is set the numerator equal to 0, and that's where it hits the x-axis at -2, 0. Now, this CV. CV stands for critical values. You are going to take the numerator and the denominator. This is tricky. You set the numerator and denominator both equal to 0. At -2 and at -1, the graph is going to change direction. Now, down below is an exclusion chart. I'm going to show you how you're going to figure out where it changes direction, right here. What I want you to do is you are going to make a number line with -2 and your critical values. So your critical values, give me a number line with -2 and -1. -2 here and -1 here. That's our number line, right? Now, you're going to make a little chart here using all of your factors. What factors am I talking about? I'm talking about x plus 2. I'm talking about x plus 1. And then you have to do this. This is important. You're going to write f of x or y. Now, what you're going to do is you're going to think of a number line. think of a number line. Here's a number line, right? That's 0. All the numbers to the left of 0 are negative and to the right are positive, right? So what you're going to do, you're going to take this factor, x plus 2. Where is the 0? It's right here. So to the left of negative 2, these are negatives and these are positives. Think about it this way. If you were to pick a number to the left of negative 2 and put it in here, all the numbers would come out negative. If you were to pick a number between negative 2 and negative 1, like negative 1.5, and put it in here, you get a positive and a positive here. For this one, x plus 1, where is the 0? Is it here or here? Right here. Here's your 0. Negative 1 is your 0. So to the left of that, see, to the left of 0 are negatives, and to the right are positive. So these would be negative, and this would be positive. Now, what's this f of x? You're going to count the number of negatives that you have in that column. If it's an even number, it's going to be the graph. This is going to tell you where your graph is here. So you're going to count. How many negatives do you have here?
2.
So it's positive. This is going to be 1, it's negative, and this is positive. So see this? Positive, negative, positive. That's where the graph is. Positive means it's above the x-axis. Negative means it's below the x-axis. Okay? Positive means above the x-axis. So, reading this chart, it's telling you from negative infinity to negative 2, your graph needs to be positive. So, everybody look, I'm going to take this piece of paper here and focus. Here is negative infinity to negative 2. How can I draw something, and they're mostly branches and parabolas? Where would I construct, where do you think common sense is that I would draw my graph? It says I need to be in the positive region. Where's the positive region? From here to here is positive. So I don't want to be in this region at all. Look, I'm a little crazy there. I can't be here. I can't be here. Okay? So where will I be? Anyone know? I'm going to be right in this little tunnel right here. And I want to pick up this point, because that's a root. Now, read my chart again. From negative 2 to negative 1, here's negative 2 to negative 1. It says I need to be in the negative region. So I can't be in this region right here. I'm blocking it out. So where do I go? I'm going to come down and follow my asymptote. Next. From negative 1 to positive infinity, I'm in the positive region. So look where I'm at. I'm talking about, here's negative 1 to infinity. I'm in the positive region. So I don't want to be in this region at all. That is because it says positive according to my bottom line. So how will I draw a graph, a branch, but I need to pick up this y-intercept. So what am I going to do? I'll go like this. And just follow along. And there's my graph. Now, these shaded regions are not the graph. These are the stay away part. You don't want to be in that region. It's a visual. Let's keep doing them until you get it. Number 2.
Vector.
Number 2. What should we first do? Let's see if you guys can step this up a little bit. What should you first do?
The horizontal.
Factor. Well, you can check what your horizontal is right now because it's already.
You could figure out your horizontal asymptote. That's a good point because it's not factored. Want to do that right now? What is it? Y equals 1. I would graph it right now. Where is y equals 1? Now, why do you think these asymptotes are important?
So you won't
Give you boundaries.
It gives you, yeah, it gives you your boundaries, exactly. How about, let's do what Nick said. Nick, what did you say to do?
Factor.
Factor it. How do you factor this numerator? And then what? That's what I got.
Give a whole.
Oh, we have a hole. See, right away, you saw it. Where's your hole?
At 30.
Where?
Is that 30?
3 what? 3 what?
3 minus
Put a 3 here. 3 minus 2 is?
1.
And what's 3 minus 1? So at 3 1/2, normally at 3 we would have had an asymptote, but you're just gonna make it a hole. So nothing can go through this, because technically, you guys, it was an asymptote. So it was stay away from any point on this line, so it shows up as a hole now. So when we do this problem, we're really doing x minus 2 over x minus 1. That's what we're gonna graph. Can you tell me what the vertical asymptote is? X equals 1. So what you're gonna do at x equals 1, you're gonna draw a vertical line here. Okay. How about the y-intercept? Can you do that?
2,
0, 2. When you plug 0 in here, you get 2, 0, 2. Put a nice colored in circle right there.
Miss Holly,
Yeah.
what's the line at 3 that you put?
The line at 3.
At the hole. In the
A hole, right here,
Yeah, like why'd you?
a hole occurs when you cross an asymptote. This is really an asymptote, but you cross it out. So you have a hole, we talked about this yesterday. You have a hole at 3, you plug 3 in to this. 3 minus 2 is 1, and 3 minus 1 is 2, so 1/2. So it would have been an asymptote at 3, but instead you can't have anything go through this point right here. Why can't anything go through here? Because when you put 3 in this problem, if I were to put a 3 in here, you'd get a 0 in the denominator, and you can't have it. Now, do you remember what I said the root was? The root is, you look at your numerator, and where it hits, you're gonna set this equal to 0. So 2, 0 is your x-intercept. Now, I'm gonna erase this broken line that I drew because it's not, it looks like you can't cross that line. I just wanted to show you that it would have been, if it didn't cross out, it would have been an asymptote, but it's a hole. So without me doing an exclusion chart, if I had to predict, but I am gonna do the exclusion chart because I wanna show you. If I had to make a prediction of what my graph would look like, does anyone think they know what it would look like before I tell you? Because you got these boundaries and then you got these points. Anyone think they know what it's gonna look like? This is my guess. I'm gonna guess, I'm gonna do it real white. I'm gonna bet it looks like this. Like that. So I'm gonna bet from negative infinity to 0, or to 1, I should say, it's gonna be positive. And then I bet it's gonna look like this. Come down here. I bet it's gonna look like that. Let's see if I'm right. It makes sense. Okay, so what are your two critical values? 2 and 1. So I want you to make a chart here, a number line with 1 and 2. And I want you to focus on those two factors, x minus 2, x minus 1, and then f of x. These are this is x minus 2, x minus 1, and f of x. So find your 0 for x minus 2, it's right here. So, to the left of that are what numbers? Negatives. So, we found our 0 here, it's 2. These would be negative, and this would be positive. Find your 0 here, x minus 1. It'd be 1 right here, 1. This is gonna be negative, these are gonna be positive. And now we count. How many negatives do you have in column 1?
2.
So it's gonna be positive. Negative, positive. So let's see if we were right. From negative infinity to 1. Negative infinity to, here's 1. Where did it say we should be? Positive. So is this all positive right here? So it should be this. All right. From 1 to 2, it says we should be negative. Here's 1, here's 2, we should be negative. So this would be negative. And then from 2 to infinity, it says we're positive. So we're not gonna pass this asymptote. And we're not passing through that hole. We're jumping over the hole. Any better? Kind of. And you know,
chart real quick, your exclusion chart.
so there's your graph of it. We're gonna skip 3, we're gonna do number 4. We're gonna skip 3, we're gonna do 4. Okay, number 4. Help me out. Out of these things, what can you do? The what?
Horizontal asymptote.
We can do horizontal asymptote, what is it? Yep. What else? What do we do?
Fair.
How do you factor this? Okay, so now what? Huh? I heard a hole. Where's the hole? At where? 1 what? 1 what?
1, plug it in.
Okay,
Negative
plug
1.
1 in here. What's 1 minus 2?
1, -1.
Negative 1 over 1, which is negative 1. So, do you all agree we have a hole at 1, negative 1?
Yeah.
How are we going to designate that hole? Okay? Next. Oh, we have a vertical asymptote where? Yep, x equals 0. I know we have a root. Where's my root? 2, 0. At 2, 0 is a root. 2, 0. What's my y-intercept?
Okay.
Where is it?
How do you graph
It's
that?
undefined.
Why is there no, why do I have a sad face there?
Because it's 0 at the bottom.
Because that's an asymptote. That's like a zap, that'll zap you. You can't be on this line. So you're not gonna have any point on that line. Why? Why can't you have a y-intercept?
Because it should never come in contact with
Because when you plug 0 in for x, what happens? You get a 0 denominator. Stay away from any time you get a 0 denominator. So that's a rarity. You know, that's going to happen occasionally. There's no y-intercept there. Okay? Now, what are your critical values? 2 and what? And 0. So let's organize 2 and 0.
I have a question. How do you put that on the test if it's just like if the asymptote is at 0,
Just
are
put
you
a frowny
sure
face.
just put smiley faces?
No,
What's
just
the
write
deal?
none. Write none. Just write none. I was just trying to get you to think, yeah. Okay, what am I gonna write here? My exclusion chart, my critical values are 0 and 2. Wherever you get a 0, any place in the problem, it's a critical value. Like, in other words, something's gonna happen. Like when you watch a movie, and you hear the music go, yeah, when you hear the music change, what do you know is gonna happen? Something's gonna happen, so you pay attention, right? So think of a critical value is anywhere in the problem where you get a 0, there's a change is gonna occur. All right, now what we're gonna do is put x minus 2 and x, and then f of x. Now I bet you guys could figure out, without even doing that exclusion chart, if you had to predict, make a prediction on what this graph's gonna look like, anyone think they know what it's gonna look like?
Yeah, something like that.
I'm gonna say something like this, and then something like this.
That's what I'm saying, man.
Anyone agree?
Yeah.
I bet that's it, so let's do it. So let's find our 0 here. It's gonna be, there's the 0, so these are gonna be negatives, positive. And this one are zeros here, negative, positive. And look at that, count, positive, negative, positive.
So you don't do the holes on those? You don't do the
No.
hole?
I feel like that's always going to be the thing, because that's how it looked the last time too.
It happens a lot. So from negative infinity to 0, it's a positive, so it's above. Now, why am I not gonna draw something here? Because this is technically positive also, because of these two asymptotes. It's kind of like when you have a little doggy and you fence in, you do an invisible fence. This is their little, that's the little playground right there. Okay, like my analogy? Then this is gonna be negative, negative, and then from 2 on, it's positive. So why am I in this region now? Because this is a way to connect and be positive, but yet you don't wanna cross that asymptote. See that?
I'm like really confused on how you get this like chart thing and how you graph it.
The chart you make up with your critical values, your factors here,
Okay.
and your zeros and your factors. So I got a 0 at 2, I got a 0 at 0, and these are my factors, x minus 2 and x.
I don't know how you like, I don't know like the negatives and the positives. That's
Okay, think of a number line. Think of a number line, x minus 2, okay? Once you get your 0, any number to the left of 0 is negative, and any number to the right is positive. So if I give you the number x minus 2, okay, x minus 2, think of negative 2 is going to give you a 0, right? This is going to 0 it out, right there. I'm sorry, at 2. It should be a 2. It should be a 2. Okay? But if I pick a number like 1, 3, 4, 5, how about 0? So if 2 is going to give me a 0, any number that I plug in here, like let's put a 1 in. If I put a 1 here, what's 1 minus 2? Is it a positive number or a negative number? A negative. Any number is going to be negative on this side. And any number after 2, like even if I did 2.5, what's 2.5 minus 2? It's going to be positive, it's going to be positive, all of them are going to be positive.
okay, then like, but how do you graph it though? Like,
You don't graph that. You graph, you gotta count how many negatives you have. And positive just means you're above the x-axis. Negative means you're below the x-axis. Do you know x-axis? Here's your x-axis. Positive means you're in this region. Negative means you're below.
So if you have 2 negatives, you'll have a positive.
Uh-huh.
Okay.
So 2 negatives here is positive. So that means from negative infinity negative infinity to 0. Here's 0. It says that we need to be above the x-axis. So here's above the x-axis. So I drew something in this region. Okay? And then from 0 to 2, it says negative. So here's 0 and here's 2. It says that we have to be below the x-axis. This part is below the x-axis. And then from 2 to infinity, here's 2, and here's infinity, it says positive. So we have to be, we're gonna be above that x-axis, okay? Let's do another one. Number 5. Okay, help me out. I'm gonna do less talking, I wanna hear you guys.
The horizontal asymptote is 1.
Talk louder.
The horizontal asymptote is 1.
Talk louder, I'm sorry.
The
Horizontal
horizontal
asymptote is y equals,
One.
y equals 1. I didn't mean to say that. Y equals 1. Maya, I'm sorry.
It's okay.
I love you. Y equals 1.
That's a.
Y equals 1. I shouldn't have had that day off. Okay.
Sorry.
Next, what do you do?
Faster.
Factor x. What else?
Minus one.
X minus 1.
Good job. Next. This is a long one.
X plus 3, X minus
Mm-hmm. Is there any hole?
1. No.
Mm-mm. None. What else?
Y-intercepts, plug in 0.
Ooh, y-intercepts, okay. Plug a 0 in. And when you plug 0 in, what do you get? So, Sam, did you get that? When you plug 0 here, here, and here, you get 5 nines, actually negative 5 nines.
Okay.
Okay, that's the y-intercept. And all I did was put a dot at 0 and kind of like in the middle. What else? What's your VA?
Negative 3 and positive 3.
Yep, x equals 3 and negative 3. How are you going to draw that in?
One.
Broken line. So far, okay?
Yep.
How about your roots? Your roots are the numerator. What are they? 5, 0, and 1, 0. There's 1, 0, and here's 5, 0. Your critical values, there's 4 of them. What are the 4 critical values? 5, 1, negative 3, and 3. 5, 1, negative 3, and 3. Where do these 4 numbers show up?
Annoying.
They're annoying.
Yeah.
Here they are. I'm gonna do my exclusion chart on a separate sheet because I don't have a lot of room.
Yeah.
So I'm gonna I'm gonna draw a number line. And how do you organize 5, 1, negative 3, and 3?
Negative 3.
Negative 3 would come first.
1, 3,
Now it's important that you get these numbers right. 1,
3, 5.
and so on this side are those factors. X, it doesn't matter what order you put them in. X minus 5, X minus 1, X plus 3, X minus 3, and what's the grand finale? F of X. That's where you're gonna count.
Exclusionary chains.
Okay? Give you a second to make sure you have that somewhere. Everyone have that? Okay, let's put in our negatives. Now Sam, tell me if this part makes any sense. See this factor right here? which of these gives you a 0?
Everything to the left.
So 5 is the 0, this is where you get a 0, right? So everything to the left are negatives, and to the right is positive. Think of a number line. Okay, next one. Which one's gonna give you a 0 here? 1, right here. That's your 0. So the left of 0 is negatives numbers, and the right's positive. Does that make sense now?
Yeah.
Okay, now this one, 3. It's gonna be a negative 3. So this is gonna be a negative, and these will all be positive. And then what's this last one? 3. That's your 0, negatives, positives. So let's count. How many negatives do you have here?
4.
4. So what's that bottom line gonna be?
Positive,
Positive. How about this one?
negative, positive, negative.
So now we're gonna go to our graph. And this is where the music changes. Dun, 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 at -3. -3, the music changes. So before, everything, so think of everything, the story's good, it's positive, everything's positive. Then all of a sudden, dun, 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 you hear something bad happening, something bad's gonna happen, you're gonna be negative. So think of it that way. All right, does that make sense? So, where's -3? I'm kind of putting them together here. Here's -3. Where are we gonna be?
Positive.
Positive. So, what do you think you're gonna draw? You're gonna draw like a branch. These asymptotes are kind of like magnets. The graph is gonna get closer to that, but not cross it. Does that make sense? Next. From -3 to 1. So give me where -3 to 1 is. It's right there. There's -3 and 1. What's happening? Something bad's happening. We're in the negative. So we're gonna be down here and here. We're still negative all the way up to that. We're gonna pick up that point. Then from 1 to 3, where are we? Positive. So what's happening? 1 to 3, we're positive. Three to 5, we're negative. So this one is saying that we're crossing. Three to five, we're negative. And, okay, this is an example,
When it crosses.
when it crosses. This is gonna, it can cross a horizontal asymptote. That stuck me for a second. Yes, it can cross and it's going to cross here. It's because it's gotta stay positive. And then from 3 to 5, it's saying negative. So here's negative, and then positive from 5 to infinity. So, the strange thing with horizontal asymptotes is it can cross. And if it does cross, it's gonna cross right around the origin, the middle area. But why do we have horizontal asymptotes? It's more for the end behavior. It's for the end, the extreme parts. It gets closer and closer, but it won't cross at the ends. So that one, it did cross, it's gonna cross there somewhere, okay? Let's do another one. We might get one more in. Number 6. How do you factor this? Or give me an asymptote or something.
The horizontal asymptote is
Horizontal asymptote is y equals
0.
0. Why is that?
It's bottom half.
Because it's bottom heavy. Y equals 0. Good job. How do you factor this? Okay, factoring it is x
Negative.
plus 3, x minus 2. Is there any holes?
Positive
Nope.
3 minus
Positive 3, negative 2. So is there a hole, you guys?
No.
No. What else? You tell me.
Vertical asymptote is
What's the vertical asymptotes?
Negative 3 and
-3 and 2. How do you do that? You're gonna draw a vertical line at -3 and 1 at 2. And there, what did we say the horizontal asymptote is? Y equals 0, which I'm gonna draw right now. What are your roots? Roots are where? -6, 0. The numerator, when you set the numerator equal to 0, you get -6, 0. I'm gonna put a dot right there. There's my x-intercept. How about the y-intercept? When you put a 0 in for x, what do you get? 0, -1.
Shouldn't it be up above
Yeah.
-6?
Did I?
It's supposed to be on
Say
the
it
horizontal
The
asymptote.
one
-6, 0.
Oh, yeah. Sorry, guys. My head's twisted.
Yeah, and can we be on an asymptote?
Yeah, yes, on a horizontal one. Yes, you can. You can be on a horizontal one, not a vertical one. Yep. That's why horizontal ones are weird. Now, what are your three? There's 3 critical values, -6, -3, and 2. Now let's do our exclusion chart. Let's organize them. The smallest is -6, then -3, and then 2, and do your table like that. So x plus 6, x plus 3, x minus 2, and f of x. So let's put these pluses and minuses in. So tell me, what do I do? Here's your 0, you're gonna have a negative here, and these are positives. At -3 right here, you have a negative, negative, positive, positive. Here, negative, 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 positive. So the grand finale is negative, positive, negative, positive. So we want to be negative, then we want to be positive, and we want to be negative, and then we want to be positive. Okay, so -6, it says negative. Now, remember what I said? These asymptotes are for the end behavior. So what's happening is your graph is coming from there, and it's gonna pick up, it is gonna cross this horizontal asymptote. From -3 to -6 to -3, it says we're positive. So we're gonna shoot up here, like that. From -3 to 2, it says we are negative. So what I would draw is like a parabola. I'd pick this up and shoot down here. And then from 2 to infinity, it says positive. I'm gonna draw something in this region. And that's your graph. It does. Okay, you've got 2 for homework to do. 7 and 8 are your homework problems.